welcome to the lecture 7 of the Learning About Learning lecture series, and I hope you have been enjoying this course as much as I do. And until now, what we have seen so far is that how we can describe the development or the evolution of the associative strength when there are multiple exposures to the CS-US events that have been happening, right. So, we talked about 3 main experiments: the experiment concerning contingencies by Rescorla, the experiment concerning selective CS-US association by Garcia and Colling, and the ability of pre-learning in blocking new association formation in a compound stimuli by Common. And we also formulated a Rescorla Wagner model or a framework for describing how associative strength or learning in this case develops over a period of repeated trials that are being presented to an animal. The trials here refer to exposures, any exposure of CS and US combinations. In summary, the model goes pretty much like this. We can write down the response, the change in response for an ith stimuli, right. There are imagine a situation where there are multiple stimuli. So, the CS there are multiple CSS. So, let us call them as each one of them, let us enumerate them, and CS1, CS2, etc. So, like that there are many such stimuli, all of them are co-presented with a single US. If you do that, right, then we are asking here how what will the response be, what will be the change in response indeed be at the end of trial number T, wherein until now T minus 1 trials have happened. So, at the trial T, how much will the response for CSI alone, CS1 or CS2 or CS3, one of the CS alone, if I were to present and probe, how much of the response change would this bring about. Now, that is given by the associativity coefficient alpha I times V max. We saw that this V max is totally determined by the US, given US, and if you do not change the intensity or the interval or the nature of the US, then that V max is fixed. That V max minus summation of the responses that individual CSS can elicit until now, until the beginning of this trial. So, that is what I represent it as Vi superscript T minus 1. So, it is not a power, but you have to read it as superscript. So, let us make it more explicit, we will call that as within the parenthesis, so that we know it is actually a superscript. So, using this we try to analyze the learning as well as the extinction data, that is when you present the animal with a repeated CS and US, we know that the animal learns, and let us say that learning, if you plot it out, the response, behavioral response elicited by the presentation of CS alone, if I were to plot out at the end of or at the as a function of different trials, we said it is going to asymptote like that, where each of these cross marks denote the data points at these different intervals, and this being the V max, which is totally a function of US. So, that is the learning, and we can say, we said that we can actually not only model the learning, but the extinction, which is also a different kind of a learning, and that is basically a presentation of the CS alone without the US, right. Once the animal has learned the CS US pairing, it needs the ability to modify itself, right. For in a future case where it turns out that the for some reason the CS is not quite well predictive of US, then it need to modify its response, right. That is what the beauty of learning is, right. You can modify its modify your responses based on the recent experiences or your past experience. So, one of them is that if it turns out that the CS is no longer predictive of US is no longer paired with the CS, then you need to reduce your response accordingly, and that is what happens, and we said that is extinction. This also could be explained by Vmax. I mean by setting the Vmax equal to 0, and could be explained by this Rescorla Wagner equation. And then we said, okay, it is good that the model there is a model that can predict the learning. Can it explain the 3 fundamental observations that I talked to you about, and then from there can we take this model to make some predictions that are not obvious until that point. So, in order to do that, we first investigated Kamin's blocking experiment, wherein we said that if you have to think of a compound stimuli, then we have to write down the response individually for the tone and the light. If you when you do that, since in a pre-learning experiment the response due to the tone, right. So, what we did was we wrote down the total change in response, right, as a response due to tone, or rather the better way to write it is the change in response due to tone at the end of the trial number t can be thought of as alpha of the tone, the associativity V max, which is independent of the tone or the light, and summation of tone and the light here. So, only 2 terms. So, we can actually write it as V tone plus V light. Good. Both of them measured at the beginning of the trial or beginning of the trial T1 or the response until the end of the trial T minus 1. When you do that, you can what you will see is that when you write for V light in a compound stimuli, right, it will be exactly the same, except we will replace the tone with the light. As a result, if you have pre-trained the animal really well, then what you are left with is this being equal to V max due to your pre-training, right, because of pre-training, right. And so, what happens is that V max minus V max, this is 0 clearly. So, as a result, this whole term, right, this is equal to this. As a result, this whole term becomes 0, is this whole term is 0, giving rise to a 0 change in response for light, right. So, no matter wherever we start, right from the first depending on how well we have trained them, right from the first trial onwards, in a compound trial where there is a tone pre-training, we have this being equal to 0. As a result, what we see what Cummins saw, which is in a compound stimuli, tone inhibits the learning of association by the light. Very good. Now, how do we explain Garcia and Colling's experiment using Rescorla and Wagner model? So, one of the key features of this model is the presence of the term alpha. So, let us write down delta V I in a trial T is given by alpha times V max alpha I times V max minus summation, right. That is the key here. Now, this term alpha can have values between 0 and 1. Now, Garcia and Colling's experiment, what they argued is that this alpha for food and stomach discomfort, right. Food is higher than alpha for tone, and they induce the stomach discomfort through X-ray or lithium chloride presentation. So, I am going to write it as alpha tone and X-ray. I am going to refer to that in future as just that. So, what their inherent argument is, the alphas for the US of the CS of the flavor, right, CS food flavor with that of the stomach discomfort, this association is may high than this the tone as CS and the X-ray as US. However, if you actually ask in the same experiment, if you actually ask what is the associativity of tone and shock, or for that matter tone, light and shock, versus if you compare that with respect to the food flavor and shock, they saw that this the alpha between the tone and the shock, where CS is the tone and shock is the US, right, that alpha is higher than the food and the shock, food flavor and the shock. So, just by the varying nature of the alpha, alpha being a function of both the CS and the US, captures the idea of Garcia and Colling's experiment. And since the alpha for one of the associative pair is stronger, so the learning in the first trial for that association is higher. So, the change in response is higher, thereby that starts to dominate, and then inhibits the in the further presentation of the trials, it inhibits the learning of tone and the X-ray association. Thus, not only Cummins experiment, we can also capture Garcia and Colling's experiments observation nicely in this alpha, the degree of associativity. And what we have shown you is that by both the alpha and the summation through the alpha and the summation term, we have seen that the Rescorla and Wagner's model captures Cummins blocking and Garcia and Colling's differential associativity observations, right. So, I am going to write this is responsible for blocking, and this as an explanation for Garcia's experiment. Okay. Comments blocking and Garcia's differential associativity. Now, where is the contingency coming from? So, the whole model, we started off this whole story by saying that one of the key features that people have observed in this associative learning is the animal's ability to capture the contingencies of the CS and US that has been presented. Let us go back and recollect the experiments there we were discussing were of the sort when you are actually presenting the CS illustrated in the blue line here and multiple CSS in a single trial, in a single exposure. US is presented once in a while, sometimes in a sometimes presented along with the end of the CS, but sometimes not. So, this versus a totally random manner. So, the random manner meaning the CS is pretty much the same. However, the US, the electric shock, is presented not just along with the CS, but also somewhere in between. Now, when you compare, so that is the CS and this is the US, right. When we compared these two experiments, what we saw was that the animal refused or animal did not learn the association of the CS and the US in this group. We call it as random group. So, during the description of the experiment, I told you that after this presentation, even though there are more electric shocks that has been presented, more USS that has been presented, the animal fails to develop a response for CS alone. Compared to this group, we called it as a contingent group. Now, how would you explain this? Because every single event of the CS US combination is presented equally in here, except in the bottom cases you have few extra USS as highlighted here, few extra USS. So, we can highlight that nicely. This is 1, number 2, number 3. So, these 3 US are in addition to the US that are present in the previous case, yet the animal fails to develop a response for the CS. How do you capture that? What aspect of the Rescorla Wagner model captures this? In order to understand this, Rescorla argued when you are actually presenting, let us redraw that CS and the US presentations again. When you are actually presenting the US in the absence of CS, the CS here that you are saying that is absent is the CS, okay. I am talking about the US that I have highlighted and then that were present in the absence of. So, no CS here, right, there is no CS. Now, how does this affect the learning? That is what the question we are asking. So, their argument was it is a CS defined by the experimenter. The experimenter says, hey, look, I am presenting the tone and I am coupling that with the US, the electric shock, and that's that CS, the definition by the experimenter, what the CS is, that CS is not present. But that does not mean the animal by per se is not receiving any CS at all. There are quite a few environmental cues that can act as a CS. They call it as background stimulation, background stimuli, or in general they call it as background. Now, the background, if in the absence of any specific experimenter defined or some in some way you there is no meaningful definition of a CS that you can see, even though you do not see it, the animal perceives rest of the stimuli. That's different from its everyday life. It looks for things that were not present in its everyday life until this point, but it is present there. For example, this could be the fact that the experimenter took the animal and placed him in the apparatus where it is receiving the electric shock. In that case, that whole setting would serve as a background. Now, that background, the animal associates that background with this US. So, granted, the CS defined by the experimenter, in this case tone, is absent. However, this background is present at this point in time. You may rightly argue, hey, wait a minute, that background is present all throughout. Granted, it is present all throughout. So, the way you want to look at this whole experiment is not as a CS US single CS single US pairing, but rather a compound stimuli involving a experimenter defined CS, in this case tone and background, which you can't avoid, but the animal can pick out the things. So, it is really a CS defined by the experimenter that is present only at this point, but there is also another CS that is present all throughout until from the start of the experiment until the end of the experiment. They called it as background. So, any experiment that you want to do, you want to think of that as a compound stimuli presentation paired with the US. Now, as you can see, if this were to be truly random, then what does it mean? A random presentation would really mean, by definition, number of US presentations without CS would be more than the number of US and CS, right. I am here assuming that the time interval between the CSs are higher than the duration of the CS put together, right. Given that since that duration is high, the chance that you would see US in that time window is going to be, I mean, if it is purely random, you would expect this to be the highest, that is the occurrence of the US without the CS being there. That is the hallmark of randomness. If you have done that, or even being equal, then what we are doing is that there are more number of pairings of the US and the background than the US and the CS. Okay. Now, my argument is going to be that such a biased presentation of one stimuli being higher in number than the other is sufficient enough to draw or to make or suppress the learning of the experimenter defined CS, and that is really what is happening here. So, if you go back in this experiment, because of this suppression of the US's association with the background. So, you can see the US background associations can happen in these many places. These individuals gain in associative strength such that when a real event happens, granted this is a summation of CS tone plus CS background coupled with the US here. However, when it comes to this point, the amount of learning that is left, because V max is fixed here, right. So, the amount of learning that is left, the amount of response that the animal can increase to the tone alone is very moderate. If you repeat it enough number of times, what I will try to show in the next lecture is that in fact you would overshoot at this point the animal's response to a tone. So, by it corrects itself such that eventually over repeated presentations the CS, the tone acting as a CS alone is not capable of eliciting any response. All right. We will see that in the next lecture.